Welcome to this video on the BatBug software, which is intended to make long monitoring periods and large data volumes very manageable. It can show up to 6 files at once. These can be from different locations. They'll always be shown in synchrony. They can be shown at different time scales. The zoom range is more than 1 billion to 1. Different aspects of each file can be shown, and you can filter by species group or even individual species where they're available. So the menu here comes and goes if you move the mouse across the top of the screen. And first of all, I want to show you the process that converts a BB1 file, which is basically what you get from the BatBug, into a BB2 file in which the bat calls have been identified. So here you can see the frequency content of the calls, and it's speeding through this here. It's completed that. So we'll now open that file and show it from the start. Okay, so it's 9.5 days. The black lines here show the total number of waves recorded, and that's sort of going off the scale a bit here, so I'm going to scale that down. Okay, so in the top panel we've got the bat calls. We've got the light level, so that's night, this is the day. So we've got the air temperature, and we've got the mixture of frequencies in all the calls recorded in 30-minute periods, sort of piled in on top of one another. So we can zoom in somewhere like this where we've got sort of apparently 3 species. Yeah, and you can see there's greater horseshoes, lesser horseshoes. These are going to be pipistrelles, and the red is probably going to be pipistrelle social calls. In the lower panel we've got the amplitudes. So let's just try zooming in here. So if we take a 10 millisecond per pixel display, and we go for, say, showing at least 60 calls in a screen, and we'll start off with constant frequency bats. So show from start, scroll right. So these are lesser horseshoes, and here's a curious thing. It's clicking at about 100 or calling about 111 kilohertz, and then it jumps to 115, and here it goes the other way around. This could be the Doppler shift, but normally you expect that to be higher as the bat flies towards you and then get lower as it goes past you and goes away, but it's sort of still getting louder, so it is a very interesting finding. And if we go back to seeing the whole screen and we graph this, we get these 2 very distinct peaks, which one of them is the 111 and the other is the 115. So that's an interesting thing. Maybe we don't want to dive into that too deeply here. We can look at, if we use the species filters, we can select a none there and then choose to see greater horseshoe bats. We won't get 60 of those in a screen, so we'll just reduce that to 1, and we'll just see what the whole thing looks like. Yeah, so we've got a group of greater horseshoe calls there. Okay, so now we can look at it at a higher resolution. Show from start, scroll right. Okay, so this is kind of typical greater horseshoe calls. This blue line up here shows the third harmonic is being detected quite strongly there. Okay, so then we could go back to using the generic classes here and look at pipistrelles. And we'll look for a kind of good number, maybe 80 calls show from start, scroll right. So this is a 15-second screen roughly, and these are very typical pipistrelle calls. I'll just zoom in on these, and you can see the sort of hockey stick shape that they have. Okay, these colored points are added by the software to mark particular features. The minimum slope is in green, there's maximum slope, the biggest rate of change up and down, and those little green blobs at the bottom are quite useful for distinguishing them from FM bats. So we'll maybe look for a slightly smaller number there. Show from start, scroll right. Okay, so here's an FM bat. If we zoom right in on these calls, they don't have any of that hockey stick shape. Scroll right, and this is rather interesting. So the frequency's gone off the top, so I'll just increase the frequency scale. So these are going from 167 down to 31. So this is probably Natterer's bats, one of the more identifiable of the FM bats. Okay, here actually we've got pipistrelles. So if I ignore all the filters so we can see those, you can see the social calls made by this pipistrelle coming in here. Yeah, so okay, so I'd like to just show you a larger file, because you can with solar panels get much longer. Yeah, I should have opened the file set there, but this is the same. So this file is 350 days long, recorded in a single session. If we go to the analysis page here and analyze file 1, it's reading a year of the raw data, and it tells us that 32 gigabytes, the size of the SD card, would last 55 years. So it's very effective compression, but we still have very high resolution on the calls. So we could just see the whole display. So this line is the temperature. This is the 9th of January. So it was running from October 23 to October 24. um, and it's got a number of species. Um, if we analyze the yeah, the kilohertz, okay, and we'll just look at the pipistrelles here. So this is going to give us the raw data, and the pipistrelles, they've got a modal frequency of 47 kilohertz. That's what we expect. But if we choose to use the frequency, the species filters, we could look for soprano pipistrelles, um, and there's actually very few of them here. And rather than going all the way through, which it reads through fairly slowly, I think I can jump to it. Yeah. So I've just marked this so I can jump to it. Yeah, so this is clearly a soprano pipistrelle. It's 56 kilohertz here. If we ignore all the filters and scroll right, we'll we then come to a common pipistrelle with social calls, so that's down at 49 kilohertz. So in fact, in the whole of this file, there's only 6 flights passed of soprano pipistrelles in a year. I'll just put the whole data set on for a year, and we can just have a look at the overall statistics. You can see the number of bats detected is kind of maximal around here in July. Analysis file 2. So it's got 1.7 million calls, of which most are quasi-constant frequency, some are FM, a few are constant frequency. Yeah, 29 million waves, that sort of cycles within the calls of the bat, and there were actually 36 million in the raw data. Okay, so that gives you an idea. You know, you can export any of this. So it is really very efficient, and the solar panel means that that whole year of data was almost no effort. You just go back and change the SD card at the end of the year, no batteries to change, and it's running again. Okay, thanks for your attention, and I hope that was useful.